Hello boys and girls, this is Mr. Giomini. Just wanted to kind of give you a little video on outliers, which we talked about today a little bit in class. Sometimes it's a concept that you kind of have a hard time deciding whether something's an outlier or not. So I just found this definition. I thought that'd be good for us to kind of work with, our working definition, we can call it that. So an outlier, a value that lies outside. Outlier, outside, lying outside, is much smaller or larger than most, keyword here, most of the other values in a set of data. So I have some numbers here, and they're nice because it looks like they're in order from least to greatest. Now, just by looking at the data real quick, before I even do anything with it, I see a 3, a 25, 27, 28, 29, 32, 33, and then an 85. Okay, now hopefully you kind of get the idea right now. I see a bulk of my data is right here, and it's between this 25 to 33 range. And then I have this 3 on the very low end, and then I have this 85 on the very high end. So looking at this data, I can see that the values that kind of lie outside of most of the data is the 3 and the 85. Now when we're doing things and we're doing our measures of central tendency, now I don't see a mode here, so the mode I would not put 0 because that means the number appears most often is 0. So the mode is NA, we could say. For this set of data, it's not applicable. There is no mode. Now, we have both the median as a measure of central tendency, and we also have the mean. Those are our three, because we're hoping that those numbers should kind of rest in the middle somewhere of this set of data. So if I do the median, it's really nice because this numbers are already in order from least to greatest. It's already arranged for us, organized. So I just cross out. I'm going to put a little x here, x under the 85, x under the 25, x under the 33, 27, 32. Now, I have two numbers in the middle, 28 and 29. Remember, if you don't know how to do this, if you can't figure that middle point, you can take your calculator. You're just going to find the average of those two numbers, the mean. So you take 28 plus 29 equals 57. I added two numbers together, so I'll divide my sum by 2, and that gives me 28.5 for the median. Now I want to calculate the mean. I always use that word calculate for mean or average because that means I have to use that calculator to solve that. Median sometimes I can do without calculation, just by crossing out front to back, but mean it's much more difficult to do that. So I'm going to add all digits together. So let me clear this out. 3 plus 25 plus 27 plus 28 plus 29 plus 32 plus 33 plus 85 equals 262. My mean's, oh wait, my mean's not 262. I forgot to do something. Remember, to find mean or average, we have to do, it's a two-step process. First step, add all the numbers and get the sum for all those numbers. Then I have to divide that sum by how many numbers I added all together, which were 1, 2, 3, 4, 5, 6, 7, and 8. So divide that by 8. I get a larger mean. Now let's think for a second. And it's not like it's a great deal larger. It's, about 4. But let's talk about why this mean is so much larger, well, not so much, but larger than the median. What could have caused the mean to become larger than the median? It is the outlier, especially that outlier of 85. Because it's so much further away. Again, 85 is 52 points or 52 numbers or 52 larger than the next largest number, which is 33. What that does is it really pulls that overall mean up and doesn't really give a fair representation of the data as a whole. So that's why as you're looking at data, you have to analyze that data and look at it carefully. Don't just put numbers in order from least to greatest. Really think, are there any numbers that are outliers? If there are outliers, are they very low? Because that's going to make the mean, what do you think? If there's outliers that are extremely low from the most of the data, that's going to pull the mean down. If we have outliers that are very high or much larger than the rest of the data in that set or most of the data in that set, it's going to make the mean extremely higher. So that's why sometimes in this situation the median is the better measure of central tendency that would represent this set of data. And just to kind of reiterate something we've been doing, stem and leaf, if I were to do this, I kind of put my, because I have no numbers in the hundreds here, I'll just put tens, and these are my ones. My smallest number is 3. What number is in the tens place in 3? It's a 0. I have no numbers with a stem of 1, so I just skip the stem of 1s. I don't need it. Now I go to the stems of 2. There are 4 of them, so I should have 4 leaves. We have a 25, a 27, a 28, and a 29. I also have stems with a 3. I have 2 of them, so I will have a stem of 3 followed by 2 leaves, 32 and 33. And now all of a sudden I have a stem with an 8. Again, there's no 4, 5, 6, 7. There's no 40s, 50s, 60s, 70s. I will not put those here. I will just put the next stem, which is 8, and there's 1 leaf of 5. Even when I do this, I could see that a bulk of my data is right here. These two really stick out to me, especially this 85. Okay, hope this helps you with outliers and making a good analytical decision when deciding to use the median or mean as that measure of central tendency that best represents a set of data. Take care.